Now we come to another very important concept in statistics, that is coefficient of variation. Now the standard deviation is an absolute measure of dispersion. The standard deviation is expressed in terms of units in which the original data is collected. For example, if the standard deviation of the height of the plant cannot be compared with the standard deviation of the weight of the plant, because we collect the height of the plant, the standard deviation of the height of the plant, it will be in centimeter or in inches. But the standard deviation of the weight may be it is in grams or it is in kilograms. So therefore these two data cannot be compared. So therefore in such cases, if the standard deviation must be converted into a relative measure of dispersion. Now, for whenever we want to do this kind of a comparison, this relative measure of dispersion is known as a coefficient of variation. And the coefficient of variation denoted as CV, that can be calculated very easily as standard deviation divided by x bar multiplied by 100. So this is how we calculate standard coefficient of variation. So let us very quickly see how do we calculate standard deviation of variation, what kind of information it gives. For example, let us see that there are two classes. So one class is, it has got, this is the first example, it has got 50 students. Okay, so therefore n is equal to 50, and let us assume that the average marks, that is the average marks they have got is 34.6. Okay, and the standard deviation, so therefore standard deviation is, let's say, 14. So, and there is another class. So here the n number of students are, it is 40 only. Okay, so their x bar is equal to 27.1. Since there is a second class, so therefore we call it, this is x1 bar and this is going to be sigma 1 bar, sigma 1, and this is x2, and now the sigma 2 of this particular class, let us say, is 8. Okay, so now we have this and we want to find, comparing these two classes, we want to know in which class the data is more consistent. So therefore it is, let us calculate. So this number n is only to give an information which we will not be using it for calculation. So we know that CV is equal to sigma divided by x bar into 100. So therefore this is equal to 14 divided by 34.6 into 100. Okay, so this is equal to 40.46%. Okay, so in the other case what happens is 8 divided by 27.1 into 100. So this is equal to 29.52. Okay, so this many, what that is a percentage. So therefore we know that when we compare these two values, these two classes, so we know that in this particular the class, okay, this is more variable, it is 40.46 in compared with the other one. It is more variable, it is highly scattered. So this is more consistent with the less variability. Okay, this is what we need to understand by this concept of coefficient of variation. So let us take one more example in order to explain coefficient of variation. So let us take this example A. Assume the height of a particular plant, maybe a pea plant. The height is, let us put it this way, let's say it is 39, 40. Another plant is 40, 41, 42, 46, 47, 49, 50 and 54. Okay, assume these are the heights of the plant which we have got. So we have the xi values. Now we need to find the variation in this. How do we find this? So therefore we know that x bar is equal to summation of all the xi values divided by n. So this we have learned in one of the videos in the very beginning, calculating mean for ungrouped distribution. So therefore, summation of all these xi value we need to find. So summation of all this, if you use a calculator, you will find that this is 448. So therefore, 448 divided by the number of observations, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is equal to 44.8 is our x bar. So once we find x bar, what we need to do is xi minus x bar, 44.8. Okay, let's write 44.8. So 44.8. What are we going to get in that? So when we do that, xi minus x bar, I'll use another pen, xi minus x bar. So 39 minus 44.8, you will get minus 5.8. This is minus 4.8. This is also minus 4.8. 41 minus 44.8 is, this is minus 3.8. So this is minus 2.8. This will be plus 1.2. This is 2.2. This is 4.2. This is 5.2. And this is 9.2. Okay, so we got the difference. Now what we need to find is xi minus x bar square of that. Okay, why we need to find? Because the formula for calculating standard deviation, what we will be using, sigma is equal to summation of xi minus x bar all square divided by n minus 1. This is the formula we will be using. So therefore we need to find this. Okay, I would have written it here little this side. So once more I am writing summation of all the xi minus x bar all square divided by n minus 1. Okay, so this is the formula we are going to use it. So therefore let us find out what is minus 5.8 square. So minus into minus plus, that is equal to 33.64. This is equal to 23.04. This is also 23.04, and this is equal to 14.44. This is 7.84. This is equal to 1.44. And this is equal to 4.84. This is 4.2 square is 17.64. 5.2 is 27.04, and this is 84.64. So when you total this, when you total that, you will get this is 237.6. Okay, so you got 237.6. So that is this value. We got it. So now let us replace. So we'll use another pen. That is 237.6 divided by n minus 1 is going to be now 9 for us, because there are totally 10 observations, root of this. So this will give you a value of 5.14. So this is the sigma 1 of the first sample. So therefore we can very easily calculate coefficient of variation from this. So coefficient of variation is equal to, so as we have seen, we have this is 5.14 divided by our x bar is equal to 44.8 multiplied by 100 percentage. So that is equal to 11.47 percentage. So remember this 11.47 percentage is what we have got in the first example. So we will write 11.47 percentage in the sample A. So let us take another sample and do the same calculation. So in the next sample, so these are going to remain the same. Just to get an understanding of what coefficient of variation is all about, let us take another example. So let us assume that the height of the next species of plant, this is going to be 40, 41, 46, 49 centimeter, another 49 centimeter, another one more 49 we'll write, 51 centimeter, 55 centimeter, 60 and 61. You see that there is a visibly there is a change, but we are not able to find the variation in that. So first of all, we need to find the x bar. So the summation of this all, that is xi is equal to 501. So we know that 501 divided by 10, so this is equal to 50.1. So therefore we replace this value. Now our x bar has changed into 50.1. So therefore now we need to find xi minus x bar. So this xi minus x bar we will find. So this is equal to let's say minus 10.1. So this is minus 9.1. 46 minus 50.1, that is minus 4.1. This is 1.1, this is 1.1, this is also minus 1.1. 51.50.1 is this is 0.9, and this will be 4.9, and this is 9.9, and 61 minus 50.1 is about let's say 10.9. Okay, now we need to find the square of this. So 10.1 square, this is equal to 102.01. This is 82.81. This is 16.81. 1.1, that is equal to 1.21, 1.21, 1.21. 0.9 is 0.81. This is equal to 24.01. 9.9 square is equal to 98.01, and this is equal to, it is 118.81. So if the summation of all these value is important for us, that value is that is equal to 446.9. So we got summation of all the xi minus x bar all square we have. So let us cancel this, okay. So therefore let us replace this into our formula. So our formula is now going to be summation of all the xi minus x bar the square of this divided by n minus 1, and we need to find the root of that. So therefore we have this 446.9 divided by 9, root of that. So this is going to give us a value of 7.05. So therefore sigma 2 is equal to 7.05. So let us calculate coefficient of variation from that. So coefficient of variation, so we know that this is equal to, our sigma is 7.05 divided by our x bar is equal to 50.1 into 100. So this is equal to 14.07. Okay, so therefore this is the coefficient of variation for the second sample. So what is important is, now the first sample has a coefficient of variation. This is sample B 11.47 and sample B is 14.07. So therefore it is very clear that sample A has less variability. It is more consistent. The data is more consistent in comparison to data B. So this is the significance of a coefficient of variation. We come to know how well the data is spread.